Hello, good morning, good afternoon, wherever you are. Thank you very much for joining us on this very special collaboration webinar. We're titling this DJI and Trimble Better Together, Base Stations, Phantom 4 RTK, and TBC. We've got a couple of speakers to introduce. First, we'll start off with Simba from DJI. Simba, would you like to introduce yourself?
Sure. Hello, guys. This is Simba, and from DJI teams, and I'm basically managing overseas geospatial channels and solutions. And today is my pleasure to, together with the Trimble, professionals, to present today's webinar and regarding to solutions by combining DJI's geospatial solutions with Trimble together.
Great. A little bit further about DJI. Simba, you are muted.
Sorry.
There you go.
So let's talk about DJI. So the DJI enterprise teams that we focus on the enterprise business, and by combining what is the DJI enterprise business that we have is, one, we have a DJI enterprise solutions, which is the enterprise drone platforms like M600 Pro, M300 RTKs, and P4 RTKs. And also we have a payloads that are designed for different industry. For example, like surveying and mapping and public safety, energies, utilities. And also we have software. By software is where define the software that to do the, for example, like flight control, to control the aircraft, do the mission plannings, and to collect the data, and to do some very primary process as well. And also, we have the after sales teams that we can take care of the customers, like whoever has the needs to fly the drones. Whenever they have the problems, we can support 24/7 support to the customers. And also, we provide the trainings, means that we teach people how to use drones professionally and to collect the data and for different industries for different purposes. Next slide.
All right, we have, I think, a little delay here. Stephen Shepard from Trimble.
Hey, how you going? So my name's Stephen Shepard, or basically everybody calls me Shep. I'm a geospatial solutions specialist based in the APAC region, Asia Pacific and China. And really what that is a technical sales representative. I've been with Trimble for a couple of years now. And prior to that, I was at the distribution partner for Trimble in the eastern states of Australia. And now I look after the Oceania area in my technical sales role. So that's a lot to do with new product introductions and assisting the dealer, training, demonstrating, just keeping them up to speed on what they need. For this particular session, figured it was relevant putting it in there. In a previous role, did achieve a remote pilot's license for drone operations as well in Australia. So I'll be taking on a little session in the mix here regarding configuring GPS as your base station for the Phantom RTK.
Thanks, Shep. And my name's Joe Blecka. I'm a market manager for Trimble Geospatial Office Software. Again, I felt compelled to throw my street cred in here. 6 years with Trimble, 2 in geospatial support, and that was really my introduction to UAVs, where I supported and trained on Trimble UAV hardware when Trimble was in that business, and then continuing on into the Trimble software for aerial photogrammetry processing across Infos, UAS Master, and then the Trimble Business Center aerial photogrammetry. In the marketing role that I currently have now with Trimble Business Center, we've led some successful collaborations with third-party UAV providers, Deliverables, SenseFly, Wingtra, and now DJI, looking to really promote simplicity and integration in office software workflows. And a large part of my portion of this presentation, we'll be talking about starting in TBC with the aerial data adjustment from the DJI Phantom 4 solution, and then staying in TBC to do the data integration with your survey data, other point cloud data sources, and then creating deliverables with the help of our nice feature extraction tools, creating surfaces, volumes, plan sets, and on and on. So what our agenda is here for today. Sorry, I think there's a little bit of a delay between me flipping the slides. There we go. We'll start off with part one of an introduction into the field solutions. So Simba will take introduction into DJI Phantom 4 RTK hardware, and then Shep will join in with the GNSS baseline base station connection with that Phantom 4. He's going to talk about the R12i, our latest receiver. And then I'll jump back in to talk about the Phantom 4 RTK data in Trimble Business Center. Barring any time and the questions that we do have coming in, we'll have some time and next steps there at the end with questions and answers. And at this point as well, I want to encourage you, if you do have any questions, please enter them into the question chat box, and we will answer them as we can. If we don't have time to answer, or we don't answer a question, we have them logged and we'll be reaching out to you afterwards. This recording, as well as the presentation, should be made available publicly shortly after the session. So if you miss anything, don't worry about it. We'll be sending you the recording as well as the presentation in a bit. All right, so part one, the field, and as the slides here come up, Phantom 4 RTK hardware, and we'll go with Simba.
Hey, Joe, thank you. Thank you for the introductions. So go through the DJI Phantom 4 RTK. So it's actually the first and very sophisticated design and all-in-one solution set offered by DJI. So it's a winner of the high precision surveying and mapping solutions that we have. And by looking at the core specs of the P4 RTKs, so basically it's all-in-one solutions that it has the RTK module on the top of the drones, and also have a 20 megapixel surveying and mapping ready level cameras, which combined with mechanical shutters and traxes, like mechanical gimbal system as well, 1-inch signals. And also by combining the RTKs and time sync and all the compensations, we're able to deliver a centimeter level of the accuracy for both positioning and the output of the map as well. And also that tool, the P4 RTK can also work with the the DRTK 2.0 as mobile stations, or like Trimble base stations like R12i. That can work with the P4 RTK as well. And also it has the GSRTK that you can use that to control the aircraft to perform the missions and for different type of the scenarios. For example, like terrain follow, for example, like the 2D and 3D map as well. Then we can have those data ready and input into, for example, like Trimble Business Center to process it. So I will introduce more about the GSRTK, which is one of the default apps that are designed by DJI. And inside that apps that we have, like 8 different very powerful functions to control the aircrafts for the different missions. For example, like 2D photogrammetry, 3D photogrammetry to collect the 3D data, and also like block segmentations that we can work for larger areas. And also like terrain awareness mode means that we can perform a terrain follow based on the DSM data that we have. Also, linear flight means that we can do for example, like adjustable height missions for different height. For example, like the power towers that in different altitudes. And also the angle fly road means that we can do the inspections for like, the side of the wall or the high buildings. So it's very powerful, and I will explain those functions like one by one. So the most common one, and is the 2D photogrammetry. It's very simple because when you open the GSRTK that you plan a mission and you simply use your finger on the screen that you can drag in an area. So once you have that area, it will intelligently and automatically come with a mission planning. So you can have a height, you can adjust the height. So there is a simple math, means that the height is equals to 36 times GSD. So whenever, for example, like if I want to fly, like this screen indicates that if I fly like relatively 100 meters above the ground, so I will have the GSD roughly around at 2.74 centimeters. Okay, and also the speed is that, you know, based on the missions that we have, that and also the overlap, that the software will automatically intelligently to calculate the speed that you can fly. And you know, simply it will set all the things for you, and you basically execute the missions, and it will do the works for you and collect the data. Once the data is being collected, and it will intelligently to return where the drone was taken off, then you simply insert that SD card from the drone into your computers and to get data and to process it. So next, the mission is the linear flight missions, and it's another like 2D type of the mission. So that way it works for a grid, for example, like the river and high speed, like highways, and you know the corridors, that you know those type of the 2D missions that we can design the missions and save the time and increase the efficiency as well, and they will do the missions for you. So a terrain awareness mode is another powerful function that we have. Is basically, you know, just like the right side, and there is a hues on the, you know, the 3D models. So what we're gonna do is, first of all, that we can actually fly the P4RTKs to, for example, like the top of the area and roughly to collect the data, and then we can generate the DSM data. Then we simply import that DSM data back to the GSRAPPs. Then the GSRPP will, based on the DSM you have, to perform a terrain photos. Just like on the left side, you see all the white dots. That's where the drone will change the elevations to capturing the data. So that will have several advantages. One is by changing the elevations, that we will make sure that we can consistently keep the same like overlaps, means that we can always have the same level of the GSD. And also by doing that, we fly the areas that also you know, in a much safer way, because sometimes there may be a, you know, large like fluctuation change of the elevations, but we can avoid that as well.
That's a great feature. I remember catching some support cases where a feature like this would have been very helpful in avoiding a crash.
Yeah, you're right. And another thing just I want to mention is the DSM data. Make sure that when you import the DSM data, then that has to be under WGS84 and geographical coordinate systems. So that's the default one. If you have any projections on it, make sure you convert it back. Otherwise, it will not read the data correctly.
Okay.
Sure. So now we move to the 3D world. So sometimes that, you know, it's not like we always have the mission for like 2D, you know, the projects, but sometimes we do care, you know, the 3D models and point cloud data. So, and we all know that P4RTK is not having a multi-camera systems, but having one single camera that we still can do 3D missions. So in the same area, like this map indicates that there are numbers from 1 to 5. So means that same area, we will fly it 5 times. The first time is really similar, just like the, you know, the 2D missions, that the sensor will facing nadir to the ground. And other 4 times, the camera will having a oblique angles that to capturing, you know, the images in different view and side. So in that case, that we will get more images for same areas from different angles. So in that case, we make sure that when we reconstruct the data, we will have enough data to make sure that we could have a very high quality 3D models on site. So another question is, people always saying, hey, the P4RTK, it's, you know, it's just the small drones and you cannot do a big jobs. Well, you know, in sometimes it's not that correct, because by turning that is also, we can have a function, means that a single remote controller, which can control up to 5 Phantom 4 RTKs to do the work like simultaneously, just like the right side that what indicates. We call that block segmentation. Smart means that we split bigger areas to several small ones. Then, for example, if we have like 5 drones, we can put the drone, so we can stand in the center of the area. Then we can split the drones for different, small box and to fly it simultaneously. So there are several advantages. One is, that rotary drones is really a good tool to do a very detailed inspection and modeling. And that's advantages over, for example, like fixed wing and whatever. But another part is like a small drones that you have more flexibilities. Means that if the mission is not big enough, I can simply deploy one drone. But if the mission is, a lot like much bigger, that we can deploy several different drones, simultaneously. That give us more flexibilities. So on the right side, you see right now on the bottoms, like we have number call from like 1, 2, 3. So that means that actually we have 3 drones that are ready to do the missions. So I can take off them like one by one, or I can take them off all at the same time simultaneously. Linear flight, it's another function, just like on the bottom, so I will indicate, because sometimes it's like especially the power towers, that they are facing and positioning at different altitudes. So that case, that for example, if we want to do a smooth like inspections and capturing the data, so we have to make sure that we know the position of every single tower. So in that case, that there are 2 ways to do that. One is that if we have that KML files, which contains the height informations, so we can simply import that KML, and that will based on the KML to perform the intelligently that mission. Or we can simply manually fly the drones on the top of the tower. Then we set the points, and by setting those points for different towers, and it will also intelligently to create and plan a mission for you. And you can perform the missions to scenarios such like power line creators situations as well. This is another function. We call that angle flight. So that case is really, we have, for example, like a side of the buildings and side of the wall. So in that case, that we can actually fly the drones to one of the, just close to the side of the buildings, and we click a point there, and then we can fly to the bottoms, and we click another 2 points, and basically you see there is a triangles. So by having that, the GSRTKs that will intelligently to generate emissions to the side of the wall and to do the inspection like that. So that actually satisfied for some very detailed and single projects, like single objects inspections and modelings, for example, like huge towers, or like some buildings that we can do that in a very, very sophisticated way. So DJI Cloud PPK is another really powerful tool. So what it does is basically you fly the drones. You can use like any like Trimble base that which can also generate a RANX data as well. So basically you when you fly the drones, it will, every time when you fly the missions, it will automatically generates every single mission folder. So under that mission folder, it will contains all the images, and also it will contains all the PPK related data. For example, like satellite observation files and timestamp files as well. And then at the same time, while you were flying the data, you put the base station like simultaneously to do the observations. But one thing, make sure that the base station should always have a longer observation time compared with the P4RTKs. So once you finish the missions, then you can simply export the RANX files from the base into the GSRTKs, and then you can upload that to a DJI server to process it, and then it will return to you a high precision post data. Then you can use that post data to combine with the images that you were taken together to process and to create a high precision map, and that's how that works. And one thing, just please keep in mind, is that this service right now is not available in the USA, Hong Kong, and Macau. And it's actually, but other than that regions that we have these services available, and the server was deployed in Frankfurt, Germany. So keep in mind on that.
All right. Well, thank you, Simba. We'll go through now with Stephen on how to use your Trimble GNSS base with the DJI Phantom for RTK. Shep, a lot of questions have come in already. You're going to be talking about the R12i, but something to consider and maybe cover during this section is, will other Trimble receivers support the following workflow that you're going to showcase?
Yeah. So they've been going through pretty hot and fast. So what we'll be covering off in this section on configuring the base stations, if you can just cue that video, Joe, is two scenarios. One of which is if we set up our base station and we are operating quite close to it with Wi-Fi range, which you'd probably be about 30 meters or 100 feet from the base station in that scenario. And then the other one where we need to set it up and we're going to be operating on a larger scale. We want to be further away from it, and we're using the cellular modem inside of the R12, either R12i, R12, R10-2, or R10 models. Now, just to answer a couple of the questions that have come through pretty quickly, the SPS 986 is capable of the Wi-Fi variant of what I'll be describing, but it doesn't have a cellular modem on board to do the cellular network connection. And there's some around our modular base stations, like our, let's say, a Net R9 or the Alloys or the SPS 855s. They would be capable of configuring some of this, depending if they have Wi-Fi on board or not. And if they didn't, and didn't have a modem, then you're looking at what's called port forwarding through the router where it's connected to the internet. I think I'll put YouTube up over the following week or so, and we'll try to push it through to the attendees for some of these scenarios as a kind of snapshot of these different configurations with some of the different applications there. So in this case, like we were sort of showing, why would we use the R12i? Like I would argue it's the best the best rover in the world. And in this scenario, it is actually one of the most flexible receivers as a base station as well, because aerial photogrammetry, it's not great when you get under trees, but you still need to do a topo survey. So something with ProPoint, really ideal for this. Also, if you're going and placing ground control check marks, then you've got that there that you can run for all of your other survey requirements. It means you've only got one piece of hardware, and then set it up and feed across your corrections onto your drone as well. So some of the additional benefits by using a Trimble receiver rather than some of the other receivers available out there on the market is when we set up the receiver and we can put it onto the exact coordinate. So it's on an absolute coordinate where it should be in the world. We're not just creating a relative RTK connection as some do. If you're familiar with setting up base stations and the terminology of a here position, which is uncorrected, then we can actually do a lot more than that. And one of the questions that popped in as well was, let's say you're very remote. Yes, you could use center point RTX to initially establish a point. And then once you've got that first position, you could be using that as your reference station that's being sent out onto the drone. So to begin with, we'll go through the Wi-Fi scenario. And if you can advance the slide there, Joe, thanks. So what we need to first do is connect to the, I'm going to say R12i, but just use that synonymously with any of our Wi-Fi receivers. So the R10 models, the R12, R12i, and SPS 986. We connect to the Wi-Fi. It'll just pop up in your network connections, and it'll be showing as Trimble GNSS and the last 4 digits. And you just hit connect in there. So once you're on its local network, advance, yep, cheers. Then what we need to do is go into its web interface. So any browser will do. In this case, I was using Chrome, but any browser. And we need to go to its address. So that is 192.168.142.1. You do need a username and password to get into here. And the initial configuration is straightforward, but generally you've bought it through a dealer and they will have done some checks and made sure that everything's operating. And on first configuration, they'll be asked to put in a secure password. It's to do with security credentials. So if you don't have that information for getting into there, just check with your dealer as to how they set this up. So once you do that, you'll be into the web interface where you can configure everything about your receiver. So in this workflow, what we first need to do is show how we've set up the base station. So we go to antenna configuration, and here, if it's set up on a 2-meter pole, for instance, then we just put the straight height coming in there and the antenna height. If it was on a tripod and you're using something like our lever extensions, then selecting that. And just to give it correlation to how you're determining the position that it is set up over. One of the things here to make sure of, just click on the antenna corrections will be accounted for as the RTCM version 3 message, and that makes sure that when it gets onto the drone, that everything's being accounted for and it should be positioning as intended for the datum that you're sending to. Next slide, please. Next up, we need to tell it where it is in the world. So we go to receiver configuration and the reference station there. And all we need to do is define a global coordinate in geographicals there. So if we're using Trimble Access, for instance, and you've got a point that you set up over, you can just change the settings in there to display the global coordinates. And what I find works well is just to click here, and that will give you a really close location. And then you're just amending the last few decimal places. You're not having to key in all of the latitude and longitude. So it gets you there a lot quicker. Once you do that, you click OK. And next up, what we need to do is tell it how we're going to send the message across. So in our IO configuration, our in-out, we've got a lot of different things we can do. And one of the good benefits of the Trimble receivers is that they have these N-trip casters. And what this allows for is us to operate it as an internet base and send N-trip corrections to anything. So it's probably an underutilized feature. I don't think many people started getting in here until we were looking at the drone workflows. And what we need to do here is find one of the N-trip casters that are unutilized. If you've never done it, just use the first one and select N-trip caster 1. And that will take you through to the configuration for that particular one. So when we're in here, if people are familiar with getting internet corrections from a service like BRS now, you'll have a listing of what we call mount points. And these are intended to give you some information around what's going to be sent to you. Because you're setting up your own one here, then you need to make sure it's intelligent. So for this, I would say call it RTCM 31, as that's what I'm going to be sending to the Phantom RTK. So that first little bit, it's got the port, we're going to enable it, we're going to give it a mount point name, something intelligent. And then down the bottom, there's a section specifically to the RTCM, and we'll enable that. And then I've screen grabbed out a section here. I should have changed over, but we want RTCM version 3X, which will send out the 3.1 message, not the 3.2 message. Make sure you do the 3.1 message because then it will have a more stable connection to the DJI drone. In future releases, that may be enhanced that you can use either, but in current testing, the 3.1, which will show up as 3.x, is the preferred technique there. So just click OK on that, and next slide, please. Okay, now this one is a little bit optional. I mentioned at the start that you'll need a username and a password to get into the web interface itself. But when you're trying to connect the drone to the base station, you don't want to have to put in an administrator password that's potentially a lot of characters and is just a bit of a pain. And what you can do is set up a number of different user profiles. So what I tend to do is set one up just called N-trip, or you could give it whatever name you want, but it's really straightforward. So then the username is N-trip, password's N-trip. So when I'm on the DJI controller, it's easy to key in, and the only thing that accesses to is the N-trip caster. much easier than trying to punch in long passwords and get it wrong potentially in the field. So it's optional, but I'd highly recommend just adding a security password in there for an additional user. So once we've done that, then we jump onto that's everything we need to do inside of the R12 base station operation. We'll go on to the ground station app for the Phantom RTK. Now, we need to connect it onto the same network because we want to get corrections from the base into the drone. It has to be connected in some way. So we just swipe down from the top there in Android, and it will bring up the Android menu. And if you could go next slide, which should look something like this. So from there, we switch on the Wi-Fi, and again, you'll see, next slide, it will pop up with our Trimble GNSS. Once we connect to that, then we just go into our fly section and go to the menu up in the top right-hand corner. And once we're in there, this is where we configure everything as to how we're getting our corrections. So there's a little RTK section here, and I tell it the IP address of the corrections. So similar to, you can actually use VRS now for this type of thing also, but predominantly what we've found in Australia is quite a lot of people wanting to host their own base because it gives a bit more flexibility around how they operate. So we point it at the same location of where that web UI is, because that's where it sits on the network at the moment, on its what we call a Wi-Fi access point. We give it the port as being 2101. If you recall a few slides back, we were defining an N-trip caster number 1, which was 2101 as the port. And then I've easily got the N-trip username, N-trip as my password, and the mount point was RTCM 31, just to give me an idea of what's going to come through on that. We hit connect and we're ready to fly.
Hey,
and
Shep,
we're getting
question came in here from Brian. That's appropriate. Is the Wi-Fi setup here connecting to the drone, or is it connecting to the controller?
It is connecting to the controller. So the connection is the receiver is hosting on what we call a Wi-Fi access point. The controller is consuming the corrections down, and then we would use, I believe it's called, is it OcuSync Simba as the terminology, is going from the controller out to the drone as its longer range connection.
Yes,
yeah.
That's called OcuSync.
So when we're using this Wi-Fi scenario of getting our corrections, we have to keep the controller in a radius that's supported as our Wi-Fi connectivity range, which I would generally say if you stay within 30 meters or 100 feet would be fine. Most of the time you're going to set it up and stand pretty close to it anyway, but the drone doesn't have to stay within that. The drone has its same range that you would expect from the DJI drones, which I think for these is about 8 kilometers or so, which is well and truly outside of where you'd see it, depending on your local regulations for visual line of sight operations.
Thanks, Shep.
Okay, so then we've got to speed through. It's a pretty big session today. Jumping straight back into the web UI. So everything up to that point consistent. If we wanted to set up the base station, let's say we were doing a really large, scale topographic survey. It might be 10,000 hectares. You don't want to have to pick up the base and keep moving it around and around, but you've got cellular coverage. You can set up that base station and put a SIM card in. Now, this is probably one of these things where it differs. The R10, R10-2, R12, and R12i all have this onboard modem, whereas the construction models like the SPS 986, they don't have that. And what that allows for is just to put a SIM card in and send that correction over a bigger distance, and that's what I'll show you here. So everything in the web UI consistent with Wi-Fi, and then these are additional things to get the cellular scenario going. So we head to the GSM GPRS modem section, and what we need to do is go to configuration. And in this case, we actually have a drop-down list for the country and the providers that we know of in the country, and also the type of plan or correct service that you're going to be connecting to. The bit that you have to define is the access point name. So how are you actually utilizing their service to get onto the internet? Each provider is a little bit different. So here I've got the kind of standard one in Australia, being Telstra, and have configured for that. Your service provider should be able to give you information around this, or your local Trimble distribution partner, if you're not familiar with it. Knock on their door. They may have already figured all of this out and save you a lot of looking at it. So once you've done that, you'll click Save and Connect, and you should, fingers crossed, see this screen where the main thing is we're getting our coverage. It's saying we're getting good 4 bars of signal, and the key piece here is that it's up and connected. We want up and connected because we want to know that we're actually online and operating. Okay, next slide. So unlike the Wi-Fi scenario where it's a fixed address, if we come down to our network configuration in our summary, you'll see this little dialog box with a PPP remote address. Now that's telling us the IP address of that receiver, where it sits on the wide area network, or like the internet. Majority of the time, this will be what's called a dynamic IP. So it's going to change. If you set it up one day and then you set it up the next day, even though it's in the same location, it won't have the same IP address. So you have to key that in all the time. And one of the things I'm going to show just in a couple of slides is how we can get around that, because there are SIM cards that provide a static IP address, but they tend to be more expensive. So you can suit yourself and do either. But if you're wanting to just use the dynamic IP, this is where you find it. Okay, and then next slide.
That was one of the question came in from Rosen on that static IP question. So you've already answered it. Thank you.
No worries. So just under the PPP config, you don't have to come in here. I'm just pedantic, and I always double check it. I make sure that auto restart was set when I did the GSM modem setup, and uses default route, so that if for some reason it dropped in and out, it's actually going to reconnect, and it's going to make sure we don't have any drop in connectivity. And next slide, please. Now, this is the bit where we avoid having to deal with the dynamic IPs. Inside of the Trimble receivers, we've implemented this DDNS client configuration. And what this is, it allows us to push through from our dynamic IP address into a fixed IP address. And there's a number of providers that we've automatically, we understand how they operate. And then from that drop-down list, we can configure that. So in this case, you could see I've used the noip.com scenario. I've set up a free account there. You can pay for the accounts. It makes them function a little bit differently and a little bit more cleanly. In the free accounts, you get some limitations. But by setting this up, I've created one called trimbledemo.ddns.net. And then regardless of where I set up that station, what day it is or anything, or where its dynamic IP address is, on the controller, all I have to do is hit trimbledemo.ddns.net with my username and password, and away I go. So that's it makes the operation of this scenario a lot easier. So if we hit OK on that and enable, it means it will actually be kind of piping through that particular IP address. So back in the ground station app, we go to fly. Next slide, please. We go to the menu again. And next slide, please. In this case, it largely looks the same, using instead using the dynamic IP address, or next slide, using this static IP, which is actually enabled through a DDNS account, which I'd highly recommend. Have a look at NoIP, set up a free account, really easy to do. They just ping you once a month to say if you want to keep renewing it, and you have a limitation on the amount of accounts you chuck in there. So yeah, we'll press on through this, and yeah, we've done a bit of testing with the R12 series, or I have, and I know from connecting out to a couple of other people, Mike Tartaglia, a bit of a shout out there, has done a fair bit of testing in the US. He's with one of the Cytex there, with the SPS 986s as well. We've got pretty successful connections. So we'll jump it across to Joe now, or unless I'll have to flick through these questions and figure out what to answer, but we'll press on.
Yeah, there's a lot coming in, so that's great. Very engaged audience. Just real quick, you'd mentioned Mike in the US. So a couple of questions came in is when is this expected to be available in the US? As far as I know, Shep, this is live, in the US
Yeah.
and available today. Yeah.
Yeah. It will work as of today with any R10, R10-2, 12, 12i, and SPS 986. The real, the bit that takes a little bit of figuring out that I've kind of gone through the pain of is the internet provider. If you're using that cellular connection, and for some reason they like being a bit cagey about all of their details sometimes, but have a chat to your Trimble dealer, and they'll have probably gone through this and installed SIMs and figured out how to get it up and running on the main networks. And then in each country, it does differ as to how you do this stuff and whether or not some providers automatically have a static IP address. Most of them are natively a dynamic IP, and they might have different what we call APNs or access point names to connect on. So it should be operational today. It's just a case of getting it configured correctly.
And one more here before I jump into the office software routine. Couple of questions have come in on whether or not you can use a Wi-Fi hotspot or some sort of internet connection to stream the corrections, via real-time network or anything. Is that supported today?
Yes. So actually, that's something I probably skimmed there. When we're using this scenario, we do need the controller to be online. The DJI controllers have a USB port underneath where you can put in a USB modem for your cellular connection, or you can hotspot onto the phone. If you didn't want to host your own base in this scenario, like what I've described, something like the VRS Now service, you can utilize that as well. Just have to be getting the RTCM correction feed from them, rather than what we deal with natively on the Trimble side, which is the CMR X or CMR Plus messages.
Okay, that's great. Yeah, there was a lot of questions on that, so I think you'll have a lot of happy attendees to hear that is supported.
Yeah.
Speaking of happy attendees, here we go with the office workflow. So the DJI Phantom 4 RTK is now supported in the latest version of Trimble Business Center. We released version 5.40 earlier this week. And if you're not familiar, Trimble Business Center is Trimble Geospatial and Construction's office software solution that enables complete field to finish workflows with confidence. There's a lot to digest in that sentence, but we want TBC to be the central data hub for all of your data, and we've kind of recommitted ourselves here to support aerial photogrammetry workflows, and we've started off here with the Phantom 4. All right, so what am I talking about? Why the benefits is why if you're not a TBC user, why you should be compelled to add another software to your repertoire, is that we're trying to eliminate the jumping around from package A to package B to package C with the aerial photogrammetry needs for surveyors and construction folks. So message is pretty simple: start in TBC, stay in TBC for survey grade aerial photogrammetry. And what this workflow looks like is you can import the DJI Phantom 4 RTK field data into TBC with a single click. There's no sort of finishing or JXL file creation anymore. With the Phantom 4 data, you can take it right from the field into TBC. TBC offers two different kind of styles of adjustment. It's photogrammetry for non-photogrammetrists, right? So there's a step-by-step method or a single menu adjustment with the deliverable creations options built in to that single menu. And then here's where it gets really compelling, is that you can integrate this aerial data, the deliverables, be it a point cloud, be it an orthomosaic, with GNSS, optical, level, terrestrial, mobile scanning. We introduced a monitoring module. We've introduced several really nice, strong enhancements to tunneling workflows. So having a project site, a complex project site with different types of requirements and data can all be integrated into TBC's pure geodetic environment. And we think that's a really compelling solution. Then from there, we've been able to create rich CAD, surface, corridor, point cloud deliverables, anything that your clients will need from you as that surveyor, as that construction professional. I've got a really nice screenshot coming up of some volume computations, right? For all you earth workers and dirt movers out there, TVC and this application integrating aerial with GNSS, for example, great way to do quick, accurate volume computations. And then if you do need to interface with other engineers or other folks using other packages, you know, we've got the appropriate industry standard exports out to Esri or to Autodesk or Bentley, or you can view in our online Trimble Clarity viewing solution. The second piece of why we think this TBC solution is so compelling is the confidence piece. So we offer features to assure that your data is accurate. So this import report, so bringing the data in from TBC, you get these statistics and the camera properties to quickly show image counts or errors or RTK status, and then the camera properties as well. The reports following the adjustment results. So you get a snapshot of tie point statistics, GCP matching, mean errors directly in the software. And then these two screenshots were the tough to decide. It doesn't do the full adjustment report justice, but we've got in-depth visual and statistical analysis of the adjustments as well. And then manual checks. So inside the software, interacting with TBC's CAD tools or the measure photo points tools or inverse tools to check that, oh yeah, you know, your GCP matches up quite well with the resulting point cloud. You know, for example, you can do that stuff manually. All right, what this workflow is, I was hoping to jump into the software and kind of stage some projects here, but it became evident with all we wanted to get done during this hour that wasn't going to be possible. So I did some screenshots here representing the TBC interface. So in the photogrammetry tab, you would first start from left to right, as much of our ribbons are set up in TBC, and you want to do your project setup. And so this would incorporate setting up your coordinate system, whether that's a known projection or a known grid somewhere. We've used Australia as a common source here. So, you know, we've got the Australia GDA 94 systems built out. Also support local sites, you know, site calibrations, localized sites as well in here. Then import data, there's a new command in the ribbon, import DJI UAV data. You're looking for the folder where all of your DJI Phantom 4 data is. And then upon import, the GNSS antenna on the drone is automatically selected. So you'll get this receiver raw data check-in screen, and you'll see that everything is pre-populated for you. The manufacturer, DJI, the type, Phantom 4 RTK. So there's nothing to change here. Quite simple. And here is where it gets really interesting and some of the really nice value adds that we've added. So with version 5.40, you can post-process your GNSS data directly in TBC. Whether you are using a local base station, or you can use TBC's internet downloads to find a local, maybe a CORS or a operating reference station to import that data in, whether it's public or if you've got access to a private, you know, where you need to put in some credentials to access the information. You can download those directly into TVC and use for post-processing. Processing the trajectory is a one-button operation. You click the process baselines button, and then it'll run through your results, and then you'd have the ability to see the processing report on the back end. And this is where we start talking about survey grade, right? This alone, assuming that the data and your correction source are accurate, this is where you can start talking about, centimeter level accuracy. However, always like to do some further adjustments, and I would always encourage the usage of accurate ground control points. Even if you don't use it, it's nice to have it, right? So then we've got the GNSS trajectory process. We'll start doing the photogrammetry adjustment, where you can then extract tie points in what we've called a relative adjustment. This is done automatically. So all of those dots there and those colored dots represent similar common found tie points across multiple images in your flight. And then you can complete a GCP matching in an absolute adjustment, where you're picking the center of targets, whether they're static or smart targets. And that looks something like this, where TVC in the 3D view gives you those graphical feedback of your different GCPs picked and from what photo station up above in your flight. Quick little experience, a tip. I found that 6 matches to a single GCP is good enough. There is kind of a point of no return, even if you could do 12 or 15 or whatever. Kind of anecdotally throughout the years, from both my experience and the experience of our support teams, 6 ground control point matching per GCP will get the job done in most cases. All right, and then we move on to the fun part, creating the deliverables, where you can create point clouds or raster DSMs or orthomosaics. Within these creation options, there's some different settings. So the orthomosaic can be a digital surface model or a digital terrain model option, and various levels of detail decided within there. And then same with the point cloud. You can represent 1 pixel for a specific ground sampling distance area. Obviously, the denser the cloud, the longer it takes to process, or the more detail in the ortho, the longer it will take to process on the desktop. And then my favorite part, here we go. Here's this stockpile creation, where we're comparing surfaces created from the point cloud, from the orthomosaic, to other surfaces if you had an original ground surface, or there is a stockpile volume computation mode in our earthworks calculator in TVC. And you get very, very accurate triangulated volumetric computations for quantities. Surfaces and contours, right? It's quite common to take your point cloud from TVC, create a surface out of it. You can then put in dynamic contour lines here, where we've got a road up top and then a nice side slope. I love this picture because I've colored the contours per elevation, so you can really see the dynamic change there and the side slope falling off of the road there. You'll notice that in both of the surface and contours pictures, and then the one I just flew up here, point cloud classification, that the vegetation looks a little too green for reality, and that's because that is representative of a point cloud, and we've run a 1 or 2 button click of an automatic point cloud classification routine, where in TVC you can classify ground regions, you can classify vegetation, structures, signs and poles, power lines as well, to put the point clouds representing those things, such as vegetation, on their own region, easily to turn them on or off. If you're, for example, want to make a surface out of your point cloud data, you don't want the vegetation to represent ground. So you run your classification, turn the vegetation layer off, and then use your ground classification to make your ground surface. And then the most exciting feature we've probably added for point cloud workflows in several years, we have added now the ability over this release in 540, as well as over the last year or so, feature extraction. So we had point-based feature extraction, so things like trees and signs and poles, where we've got algorithms that will run through and pull out attributes, not just XYZ positions of, say the base of the tree, but also things like the height of the tree, or the drip line, or the trunk diameter at a specified height that you can change above the ground. And now here recently in 540, we have released linear feature extraction. So we've got a overhead lines, power lines, extraction, as well as curb and gutter, which is what I've got shown here. These feature extraction tools and the point cloud classification tools, they work openly on any point cloud in TBC. So there's no format specific. The feature extraction, the point cloud classification work on your aerial data from DJI Phantom 4. All right, with that, we've got a few minutes here for questions and answers. Definitely not going to be able to get to everything. However, before we get there, we do have some next steps to share. Simba, can I bring you back here and you can introduce some things on DJI, as well as some really new exciting product announcements that have just happened.
Sure, thank you, Joel, thank you, Stephen, and that's a great presentations. So I think from our side, it's when you guys look at the DJI geospatial industry, so the P4 RTK is actually the base. But it's just the beginning. And as you guys may know, that this year around October, that we launched 2 new products, P1 and L1. One is the surveying and mapping camera, which has a full frame sensor and 45 megapixels. Another one is the LiDAR payloads, which combine with the basically LiDAR and camera and all-in-one solutions. So by having that on our board, so we are trying to expand and make sure that we can educate and to increase the efficiency and help the industry to grow as well. So if you guys want to visit the product information regarding to P4 RTK and DJI Enterprise products in general, and P1 and L1, and here is the links that you can click and view. And also in the future, that we wish that we could have more solutions that combine hardware and software, just like today's what we did together, and to bring more powerful solutions to the customers. So that's pretty much from our side. Thank you, guys.
Thanks, Simba. And then on the Trimble side, you can learn more about the R12i GNSS system that has also been recently introduced from Trimble. You can visit the TBC homepage, trimble.com/TBC. And then we've got two new exciting resources here. I just posted yesterday 3 new video tutorials, step-by-step walking through the TBC workflows on our YouTube channel. And if you're going to search it, it's the TBC Survey and Construction channel on YouTube. They may be the best technical Trimble videos I've ever been exposed to. Thomas in Stuttgart, Germany did an excellent job on really being thorough with the workflow. So if you want to learn more, there's more details there on the YouTube channel. And then if you want to get your hands dirty a little bit, we are also introducing a new software simulation. So you don't have to have the software, you don't have to have any data, you don't have to have a license of TBC or anything, but our marketing team has created a new learning plan in our Learn.Trimble platform that will walk you through how to complete an aerial photogrammetry adjustment with a sample Phantom 4 data, and it's like a software simulation. However, you're in the software. You know, it is a great simulation, really well done. I'd encourage you to visit there as well for more information. And of course, visit your local SciTech or geospatial distribution partner for more information regarding anything that you've seen here from Trimble as well. All right. Looking at some questions, Shep, Simba, were there any questions that came up consistently that is worth mentioning here to the group?
Sorry, just because I think because of my positions, I'm not able to see the questions. Are you guys able to make me as a co-organizer, or maybe you can, share some questions and on my side, and I'm more than happy to answer.
Sure.
Oh, I see. Yeah, I see. I saw like there are like 10 questions.
Yeah, I've been allocating some to you where I could see they were kind of ones into your sweet spot of answering, and then but it is a huge list of questions. We've really been inundated today, so we'll have to figure out getting back to these in the best way. Yeah,
Sure.
some of the ones that seem to have come up consistently, probably one to just clarify, was the multiple drone control. I think there's probably only a few countries that would allow for that.
Sure, I can answer those questions like one by one. So question number one, when DJI Cloud PPK be available for the US? So currently we do not have a plan for this because of, you guys know that it's a different policy and, environment in the US. So currently we do not have plan to have that service available in the USA yet. But whenever we have that change or any updates, and I will let you guys know for sure. And second question is, for terrain awareness mode, you have to load a DSM file on your site. And how do you get it? And do you have to create it? Yes. So there are two ways to import the DSM file. Option one is that if you already have DSM data, you can simply convert and make sure that it's under WGS84 geographical coordinate systems, and then you simply import that into the GSRAPPs, and that will intelligently, based on the DSM data you have, to create missions for you. And second option is that sometimes that you may not have a DSM data that associate with you on site. You can use the P4RTK to fly the area like quickly. You don't have to do the very accurate measurements because you just want to get a rough DSM data. So you simply fly the drones like at relatively like high altitudes and collect the data. Then you can generate the DSM data by simply import. I'm pretty sure that you can do that in TBC as well. Import the data and process it, and you're gonna have a DSM data that is under the WGS84 geographical coordinate system as well. Then you desampling it because you don't have to use the very high res pixel DSM data. We recommend that you desample that to the meter levels. Then you can import that to the GSRAPPs, and then it will, based on the DSM data, to perform a terrain follows. I hope that answers your questions. Have anyone figured out, or has DJI released the capabilities of using terrain follow when not in RTK mode or connect to a base? So I think that's the same thing. Like I said, terrain follow is really to give you a reference to perform, a mission flight in different altitudes. So you can turn off the RTK mode by performing that. It just gives you more, not very accurate results, but you still can do that for sure. Another question is, the Cloud PPK service will process the RINEX file by itself for after geotag P4 images with the high accuracy. So how that works is basically, yes. So when you import the RINEX file from third-party like base stations, and together with the the PPK related data that is automatically generated from the P4RTK, like satellite observation files and timestamp files, and simply import those data together into the server, and it will process it for you, and then you will have a high precision post data. So in that case, you're going to have two options. Option one is by flying P4 RTKs. Every single images that will already contain a geotagged information for every single images. So in most of the cases, and that is under the RTK mode. So if the RTK is always fixed, I don't see you have to do that. But if sometimes because of the long distance or some other reasons that you lost the connections of RTKs, so that will cause some of the images that doesn't have a fixed stats, means that it will affect your overall accuracy of your final results. So if that's the case, I would say simply replace the high precision post data from the high precision post file that is being created based on the calculation of the cloud PPKs. Then you can do the calculations as well. So terrain awareness elevation come from what source, like USGS? I think you are referring to SRTM mode, but like I said, like right now, it's not. We don't have a base. We don't use the SRTM way. We basically, you get the DSM data by yourself. Either you already have the data on your side, or you simply fly the P4 RTK and collect the data and to get the data. So that's the options there. And another question is, can you address the limitations of using DJI products for a US governmental projects and inabilities to use them on most energy-related projects? So I would answer that questions into two different ways. So from the scenario and the application perspective, for example, like if your goal is to do the inspection works and to do the aerial mappings, I would say why not? Those drones can definitely satisfy your results for sure. So you can use that to collect the data and the process it to deliver your results. But sometimes if you have some concerns maybe on the political things, so that's a different story. But I do feel like shouldn't bother that much. If you spend the budgets, based on your plan and your needs. If it's my understanding that FAA only allows the pilot to fly one drone at a time. Is the multi-drone platform, features indeed for the multi-pilots then? So yes, you're right. The multi-UAV controls and block segmentations, it's a function that's available, but you have to really look at your local laws and standards. Sometimes in some countries you can do that, and in some countries you cannot do that. So it's really just please refer the laws and the standards that you guys have. But on our side, we have these functions available, and I hope that answered the questions that you guys have.
Yeah, and we'll keep the questions coming here in the last few moments. If you got anything, we are capturing the questions and your contact email, so we'll be able to reach out to anybody whose questions we don't have answered or are unable to answer at this time after the webinar. All right, well, that went really well. We threw a lot at everybody here over an hour's time. Really nice job, Simba and Shep. Thank you very much for participating. And yeah, if you've got more questions, we've got those resources slides. Again, this recording will be available to your inbox as soon as we can process it. And I believe we're able to get this presentation deck out as well with those. So any closing thoughts there, Simba or Shep?
Thank you guys, thank you so much. And it's my pleasure to present today's topics with you guys. And I hope that can definitely help you guys by working together, combining the hardware solutions and also the software solution together. And I hope that we can deliver that more and more in the future. Thank you guys, thank you so much.
Yeah, just thanks for everyone attending. Thanks for all the questions. We will get back to the ones we haven't been able to answer during this session. Keep them flowing through. Yeah, it is more flexible beyond what we've described, and didn't go into a lot of depth onto some of the other things, but what Joe was talking about with the PPK workflows, there's a number of questions coming in around that, and you can operate your receiver just to log the static files so that you've got those ready to go for a PPK workflow as well, where it doesn't need to connect to the drone in the field. It's just running PPK for later on. So yeah, over to you, Joe.
Yeah, thank you. And this is the start of hopefully a great collaboration between DJI and Trimble. So stay tuned, and we look forward to talking to you again on a future call. Thanks, everybody. Really appreciate your time.
Thank you, guys. Thank you so much. My pleasure all the time.